Okay, so today we're looking at equivalent representations of functions, looking at how we can rewrite polynomials and rational expressions in equivalent forms. And one of the things we really want to do is explain how factored and standard forms reveal where the zeros, asymptotes, and end behavior are. So our first question today is to take h of x here and write an equation of h of x in factored form. So let's do that to begin with. We have h of x is going to be equal to x plus 2, x minus 2, there in the numerator. And then we need to do the denominator. We can see it's going to be 2 and 5 as our factors of 10, which have a sum equal to 7. So it's going to be x plus 5, x plus 2. Right. So now we have to identify holes, vertical asymptotes. We can even see a 0 here. So we can say that this is going to have a hole at x equal, we're going to have a hole at x equal to negative 2. Why? Why do we have a hole at x equal to negative 2?
Because x minus 2 is on the, or x plus 2 is on the numerator and the denominator.
Because x plus 2 is on the numerator and the denominator. Is that a sufficient definition of why we have a hole? Or should you add something to it?
X plus 2 cancels out.
Why? You're skirting around the issue. What are the multiplicities of the factors?
1.
They're both the same.
Oh.
So your definition was a little bit short. We have the factor x plus 2 in the numerator and the denominator, and both factors have the same multiplicity. This is why we have a hole. We have a vertical asymptote. Where is the vertical asymptote? X equals negative 5, and we're going to have a 0. This is going to be at x equals 2. So we have a factor in the numerator of x minus 2, which means we have a 0 there. So we found the holes, found the vertical asymptotes. The domain of this is basically going to be all x, but x is not equal to negative 2. So if we wish to express the domain, there's a few ways we can express it. I'll express it in different ways. So the domain is x is a member of all real numbers except for x cannot equal negative 2 or negative 5. So the vertical asymptote and the hole, they negate any other values for x. Let's try another one.
Sure.
I've got.
Just back to the last question.
Thank you.
After class.
After.
Okay. Have a go at this one. 3 minutes for this. Okay, let's start off by factoring it. So we have a 12 on the top, and we need two numbers that close. So we're going to use 3 and 4.
Thank you.
We're going to have x plus 3, x minus 4. Should factor it like that one. The denominator, we need to take out the x first. That's going to leave us x squared plus 1x minus 20. So again, we need 4 and 5. So this time we're going to have x plus 5, x minus 4. We should factor it like this. Do we have any zeros? Yep, we've got the 0 at x equals minus 3. Is there a hole? X equal to 4. Are there any vertical asymptotes? X equals 0 and x equals negative 5. Do we have a horizontal asymptote? So for the horizontal asymptote, what we can do is we're going to be looking here. If we look here, we can see that the the degree of the polynomial in the denominator is larger than the degree of the polynomial in the numerator. This means it's going to come down towards 0 in both directions. So the horizontal asymptote is going to be y equals 0. This is because the degree in the denominator is greater than the degree in the numerator. I think we looked at that in lesson 5 or 6. Find the domain of the function k. So we have 3 points for which it is not defined. We could do it as a series of, let me try it in interval notation this time for the domain. So we're going to go from negative infinity, and then there's 3 whole points of discontinuity. We're going to have 1 here, 1 here, and 1 here. So we got 3 points of discontinuity. Make sure we put them in order. So the smallest one is -5. We can't have that point. So then we go again after -5 until we get to 0. And then we go again after 0 until we get to 4.
0 is an asymptote.
And then we go up to infinity. So we can write it in interval notation like that. We have 3 points of discontinuity. We have 1 pole and 2 vertical asymptotes. The function's not defined on those points.
Can we say x goes to all real numbers except -5, 4, and 0?
Like I did last time.
Yeah, like we did.
Like I said, I was going to vary how I express the domain.
For this, what you have -3, -5, you mean -3 to 0? Why -3?
It's just a badly drawn 5.
Oh.
My 5 is not great. My 5 is not great. That's why I put my 7's really bad. My 7 and my 1. That's why I put a line through my 7. There's a few things I do. I've changed how I write just so that it's clearer. My 5 and my S. 5, S, and 2, I think.
What about your 6?
Not bad. My 6 is bad.
Can you show us our 7?
Alright, you'll the graph of a rational function is shown above. Write an equation in factored form. Alright, so we're doing the same as what we've just done in the last 2 questions, but we're going backwards through the problem. So we have a vertical asymptote. So we're going backwards through the problem. Start at the end, we have a vertical asymptote at x equals 2. We have a hole at x equals 2, 3, 4. We have a hole at x equals 4. We have a horizontal asymptote at -1, at y equals -1. So we need to go backwards through this, putting it all into the question. We also have a 0, don't we?
Is it 0
Yeah, we've got a 0 at x equals 3. So we need a function, or a function that we told what it's going to be called. It's going to be called f. We need f of x. We need a hole, and let's start with the 0. No, let's start with the hole. We have a hole at 4. So we've got a hole at 4 now. We need a vertical asymptote at 2. We need a 0 at 3. And lastly, the horizontal asymptote needs to be at -1. And this is what I'm thinking about as I've been sort of doing the last couple of steps, making sure I get it right. So for me to have a horizontal asymptote, which isn't 0, then the degree in the numerator and the degree in the denominator should be the same. And we have to have the same.
Don't we have the same?
We do have the same, because we have the same number of factors.
Yes.
So then,
Negative sign.
this is going to be -1 over. But the last thing we need to sort of check is to make sure that we're going to be having the right vertical. The last thing I need to consider is how we approach that. The left-hand limit and the right-hand limit have to be correct.
Isn't it correct if you put 0 to the value, x value, and you get like 1.1?
Yeah, so I'm just thinking, what I want to do with this one is I want to check have I got this right. I want to check. And I want to come up with a way for you which would be the easiest way for you to check to see if you're approaching it in the right direction. Because you want to make sure you're not drawing, you want to make sure that you're not drawing this. You want to make sure that you're not drawing this. So we could look at this point here. We can look at this point here, and that's why x is equal to 0. So just putting that in, we're going to get -1, we're going to get -4, we're going to get -3, we're going to have -4 there, we're going to have -2 there. So these two cancel out, and this would give us negative 3/2, so negative 1.5. And that's roughly there in the right place. So I'm just verifying down here that I have made sure that I've got it going in the right directions. And I have. So no further adjustments are required. Okay, have a go at this question for yourself.
So that's the have question. So that's why you put negative before the two others.
No, so Tanis is asking about this number here. I've got this -1 here. I've got this -1 here, and that is because in order to get your horizontal asymptote here at this point, in standard form, your lead coefficient, this is going to be something on the lines of ax squared plus bx plus c over dx squared plus ex plus f. So if I was to expand that, because I have two terms, I'm going to get a quadratic like that one. And the horizontal asymptote is going to be y equals a over g. Those two numbers. So because the coefficients inside the brackets here are all 1, the only thing that can change the value of a is any number I put on the outside there.
So it doesn't matter that I put negative top up or down.
It wouldn't in that particular case. You could put -2 over over +2 as well, and you will still come to the same horizontal asymptote. That would slightly change the shape of the graph, making it rise a little bit quicker. But no, actually, it wouldn't change the shape at all. Sorry. Yeah, that would still be exactly the same. Yeah. Have we got this one? Two minutes for this one. Okay, so zeros. Zeros. We have a 0 at x equals 1. Holes. We have a hole at x equals 2. Vertical asymptote. We have x equals 0 and x equals 3. Horizontal asymptote, we have y equals 0. So the horizontal, Okay, so the horizontal asymptote, y equals 0, means the degree in the numerator has to be less than the degree in the denominator. So let's put in our different factors. A 0 is going to give us a factor in the numerator. A whole is going to give us a factor in the numerator and that matches a factor in the denominator. Our vertical asymptotes give us factors in the denominator, so, and that should be enough. Right.
Please, sir.
Which what
Do we have to put a
Negative sign.
Oh, yes, we do. Well thought. Yeah, so just looking at how we approach 0 from each side on this one, we are going to need a negative symbol here. We're going to need a negative symbol here. Otherwise, we're not going to approach 0 from the right side. Without the negative sign, we're going to be looking like something very, very similar. So we end up with this one. You can usually tell for that type of question quite easily that if you want the graph in the final part here to be in that part, you want it positive. And if you want the graph to be in this final part here, to be below the x-axis, then you want a minus sign. That's the easy way of doing that.
The horizontal asymptote 0, but the degree is the same for the numerator, the denominator.
The degree in the numerator is 2, the degree in the denominator is 3.
I don't understand how to choose.
There's 3 x's. Okay, so here we have a function. We need to use long division to find an equation of the slant asymptote. So this part of the course draws from your experience in IM3 Extended, which is the feeder course to this one, and you might find yourself having a little bit of difficulty on this topic if you haven't done that. So what I suggest you research this in Khan Academy, where you can watch some videos on how to do polynomial division. I'm going to do a couple as examples for you. You can do it with synthetic division, but you do need to put in a fix when you have a non-integer factor like this, because this is going to have the solution to the two. Sorry, let me express myself clearly. So this factor here that we're doing the division by, if we set that equal to 0, you will get -1/2. So if you have a non-integer result here, you're better off with long division than you are with synthetic division. Synthetic division works easily and quickly when it's integers, otherwise you need a fix. So I'm going to do, as the question says, long division, or polynomial division as it's called. We need 2x plus 1, like this one. 6x squared plus x plus 5 in here. So we write our equation up like this, and we're doing a long division. It's similar to what you would do with numbers. I'm going to run through the algorithm twice for you now. So the first thing we're going to ask ourselves is, what do we have to multiply 2x by to get 6x squared? You say, let me say it again. What do we multiply 2x by to get 6x squared? We need to multiply by 3x. Because 3x is a linear term, keep it in the column for all linear terms. This helps. So I'm going to be multiplying by 3x. So 3x times 2x gives 6x squared. We then repeat 3x times 1 gives plus 3x. Now at this particular point we do a subtraction. So we need to do a subtraction here. 6x squared minus 6x squared is going to be 0. That's why we chose 3x. But we have to continue with the rest of the expression. X minus 3x is going to give us negative 2x. At this point we drop the next term down, and then we repeat the process. So repeating the process, I'm going to ask myself, what do I multiply 2x by to get negative 2x? Negative 1. That will give me minus 2x, but then I do the minus 1 on this plus 1, gives me a minus 1 here. So I do a subtraction again. Take care with your minus signs. So minus 2 minus minus 2 is going to cancel out and give us 0. But 5 minus negative 1 is going to give 6. This is our remainder. So what we have here now is we have a quotient and a remainder, and your slant asymptote is going to be given by your quotient.
Wouldn't this be negative
Cancel out.
4?
So, what we can see, what do we have to do? Use long division to find the equation of the slant asymptote. So, our slant asymptote
Minus a positive.
is going to be y equals 3x minus 1. Let me show you some tricks and some shortcuts to check that you're getting it right. Some tricks and some shortcuts to check that you're getting it right. Take the lead term in each one. 6x squared divided by 2x. What does that give us? 3x. That's this. The only thing you have to work out is the rest of it after that. So you can see the lead term quite easily. You can see that it's going to have a slant asymptote. I mean, the straight line. If the degrees were more different, let's say one was 4th degree, the other was 2nd degree, you'll get a parabolic asymptote, and you can still see the lead term in the asymptote that way, nice and quickly. All right, so we have, I think we're out of time there for today. I'll try and put a video together on this one. Slow it out, I think.